Okay, are we technically connected? Hi. Good morning, thank you. Is this a little too loud? Should I lower this a little bit? Thank you very much for attending here today. The title of this section is called From Belief to Heredity on the Role of Perception and Genes, or something close to that effect. Basically, what I really want to do is extend my talk from yesterday. And just for those that did not attend and didn't get yesterday's handout, the message company was kind enough to reproduce a bunch of these, and I'll leave them right up here in the front, and so you can pick them up there for those that did not get them, okay? So we can pick those up over here. In addition, as I left in the bookstore, because all the videos got lost, got sold. That's not lost. There are some forms here if you're interested in this 2-hour and 40-minute video, essentially of what I've been presenting here. Okay, now, the issue is this: put your seatbelts on. This is going to be fast. But the issue is I got so many wonderful things to talk about that I really feel that, that we're going to have to power through this so you can understand what's going on. I guess I'll have to wait a few seconds because we'll have to, why don't we just wait for the notes? Are the notes? Okay. Okay.
Bruce, how was it that you managed to underestimate how popular you
Well, let me start off with what I tried to say yesterday. And listen, let's just start off with this. What I said yesterday was this. There are three assumptions that conventional biomedicine holds that are not true. You know the concept of the word assume, what it does, you know, to make. Okay, well, the reality is these assumptions have taken science out of the actual reality of the universe as we perceive it. Point about it is this: when we correct the three assumptions I'm going to list, the beautiful part about it is it unifies conventional medicine, complementary medicine, and spiritual healing will all be on the same scientific foundation. So the bottom line is really it's the coming up of conventional science and medicine that is the issue that we have to work with. So let me just list the assumptions and then I'll describe each one. The assumption number one: biological processes employ Newtonian physics. What this basically says is this: that as we perceive the world according to the eyes of Newton, the world is a physical machine. And it's just like a watch with parts in it. To understand the watch, you could take it apart, which is called reductionism, and study the individual parts. And if you see how they work, you can then adjust the machine to make it work. The parts are actually what the products of the pharmaceutical industry make. The pharmaceutical industry makes these parts. Well, the problem, of course, is all of science has been bent to fill the pharmaceutical industry's belief. And the reality is that there's more to it than parts. There's energy. But in Newtonian physics, there is no entry of energy in the universe. It's in quantum physics where energy comes in. The point, as I will talk about, is that we now live in a quantum physical world. The concept of Newtonian physics is outdated by 75 years, and the issue is that medicine is no longer scientific because it no longer adheres to modern physics. It's still adhering to ancient Newtonian physics at this point. That's assumption number one. I'm going to talk about that. Assumption number two: genes control biological expression. This is what we hear and read every day in the newspaper, see it on the television, hear it on the radio. The genes cause cancer, the genes cause this, the genes cause whatever. And the bottom line is I'm going to make a brief review in a few minutes because this was yesterday's lecture to reveal very clearly genes do not control biology. Perception controls genes. And this is a very important understanding. And the third assumption, which I will address, and this is the later part of today's lecture, is Darwinian evolution provides for biological diversity. Why I'm bringing that up is it suggests then how we got here was a matter of accident, random mutations and accidents of genetics. And it now turns out that that's a false assumption, that the reality is that the genetics conform to the environment. And therefore, conform to your perception of the environment, and therefore, rather than evolution being an accident or random process, it turns out evolution was directed by the environment. And therefore, we are fitting into the environment, and if we don't fit, then we make an effort to rewrite our genes to fit into that environment. The issues, as I really will bring up and are very profound, is what if you have a belief about the environment that's not true? then what you will end up doing is adjusting your genes to a false awareness, a false environment. And that's where people get out of balance, because now they adjust their genetics to an environment that doesn't really exist because they believe it exists. I'm going to talk about that. So let's just talk about assumption 2, because this was yesterday's talk. Can I catch you up on it? Okay? And don't worry about if you lose a little bit of the science, especially after we get past the Newton physics, quantum physics part. The rest of this stuff is relevant to everyone here because it explains why and how stress produces the illnesses that we experience. That the primary problem in this country or around the world is not genetics. It is not health issues per se that we're being ravaged by the environment. What we have done is fail to understand what protects us, and that stress takes away that protection. And I'll talk about that because we're really the victims of the stress, not the victims of genes. Okay? So assumption 2, genes control biological expression. That belief gets us to believe that in the cell, in the living cell, that this structure called the nucleus, this structure here which has all the genes in it, if the genes control biology, then the nucleus with all the genes would be the equivalent of the brain, because we talk about how the brain controls the organism. So the genes being in the nucleus then would represent the brain of the cell, and that's how genes would be able to control the cell. But the problem is this: I can take the nucleus out of a living cell and the cell does not die. If I take the brain out of anything, the organism will immediately die. The moment you remove the brain from an organism, it will die. If I take the nucleus out, the cell doesn't die. Right away, it tells you something. The nucleus and the genes are not required for the behavior of the organism. That the organism can behave and respond to the environment in the absence of all of its genes. And it can last, some cells last 2 or more months without any genes in them. So the bottom line is, well, they're living for 2 months, eating and digesting and respiring and moving around and recognizing other cells and avoiding toxins and doing a very day-to-day life. It can do it without any genes. What does that mean? Well, it has behavior without genes. It has control without genes. Genes don't control it. That's the issue. Genes are not the brain of the cell. As I brought up yesterday, the genes are actually the gonad of the cell. They're for reproduction. That's their main structure. They don't say what needs to be reproduced or when, but they are there for blueprints to make the parts of the body. So, because of the limitations of time, and this is a review, where is the brain of the cell? And the answer is the brain of the cell is the skin of the cell. And in fact, even in your own embryology as a human, your brain was embryologically derived from the skin, so that it makes consistent understanding. And why would the skin be the brain? And the answer is very simple. The skin is the interface between the external environment and the internal cytoplasmic environment, cellular environment. As a result of that, the membrane is reading 2 environments and adjusting the cell to respond to the external environment. That's what maintains life. If the cell cannot adapt to the environment, the cell will die. So basically it says this: the membrane is the physical structure, the skin, between the external environment, reading what's going on, and the internal environment, which is the physiology of the system, to respond to that. How does it work? Okay, I used an illustration. Now this is a part, I hope you can catch up if you weren't here yesterday, but the review is, let me show you how the membrane works. And these are molecules in the membrane. This is a section through the membrane like a cookie cutter. This is an antenna that reads the environment, just like a TV antenna. It's reading what's going on. This is the input, this is the output. This is a connector, so that the input from the signals, whatever's going on in the environment, can activate a behavior. When the environmental signal comes, it changes the shape of this receptor and allows it to connect to the effector. These are names I'll explain in a second, which creates a biological signal. And this biological signal is what activates the cell. So let's talk about it again. I'm going to show it one more time so you see it again. The antennas are like television antennas on your house. They receive what's going on: light, sound, smell, touch, toxins, or whatever. Look at the shape of the protein. It doesn't fit the shape of the connector, so I can't activate the behavior of the cell until the signal shows up. When the signal shows up, it changes the shape and connects the receptor, the input, to the output, and this is a switch whose signal activates the biology and activates the genes. Okay? So that this unit has a name. It has a biological name because the function, I'll just explain it again. What is the function of this? Awareness of the environment. It's sensing the environment. It's like eyes, ears, nose. It's what it's doing. This is sensing the environment, and this makes a biological response to that. Stimulus response. That's the understanding of it. So the significance about the stimulus response is this. If I look at the, oops, let me go back one. Look at that protein. I said the receptor receives environmental signals. And then it connects to the effector, which makes a signal itself and activates the biology. So the switches inside my body that make me do things are switched by the environment. So that my life is really controlled by what's going on in the environment. And in fact, remember I said you can take the nucleus out of the cell and not change the behavior? Well, if I take the antennas off of these receptors, knock off the antennas so no signals come in, there is no behavior. Point. Behavior is a reflection of what the environment is. We are therefore complements of the environment. Whatever we see in the environment, we make our physiology and our body respond to that complementarity. So this is the input, this is the output. And so basically, these are the two proteins. The ones with the antennas are like the eyes and ears of the cell, and this is the one that switches the behavior in response to what this sees. The receptor is awareness of the environment. The effector, that's the output one, makes a physical sensation, a behavior. This is the control. So this unit of control has an identity to it. And the identity, as right in the dictionary, is awareness of the environment through physical sensation is perception. What does that mean? It says that this structure is a unit of biological perception, how you see the world. And so biology says this, then what controls your biology is your perception. If you have no perception, you have no adjustment of your biology. So basically you are reflecting through your perception an adjustment of your body. So the conclusion, first conclusion I came to yesterday is perception controls behavior. And this is the truth. How you see it determines how you make a response. Okay? Then and the last part of the review from yesterday, and then we'll get on to really the stuff that people came here for today, is what happens if that signal that I send into the cell, I don't have the appropriate proteins or the structures in the cell to respond to the signals? Well, then the answer is, then what happens is the signal activates the genes. And I'll try to explain that using this very quick video. Now what happens here is at the surface the receptor and the effector. The signal goes into the nucleus if the genes aren't there, and this is the DNA. But the DNA is covered up. The signal hits a special protein, uncovers the DNA, and therefore the signal activates the expression of this gene. We make a copy of this gene, and that copy, called RNA, is the blueprint to make the body's proteins. I'll repeat it again just so you see it. So the point about it is this. At the surface of the cell, these are perception units. When a signal comes in, it activates the cell. But if the proteins are not present, the signal goes into the nucleus, selects a specific regulatory protein, it's called, opens up and exposes the gene that needs to be read to respond to that environmental signal. We then make a copy of that gene, which is a blueprint, to make the proteins of the body which carry out the behavior. Okay? So the bottom line is genes are not just activating the behavior. Perception is not just activating the behavior. Perception is also controlling the genes. Conclusion. How you see the environment selects your behavior. How you see the environment selects your genes. And why this is important, as I mentioned yesterday, for example, let's say you have a cancer gene in your body. Well, when will the cancer gene turn on? It doesn't turn on by itself. As I talked about yesterday, genes are not able to turn on by themselves. They can only be turned on by a signal from the environment. So the issue is, you may have the gene and never express cancer in your lifetime. On the other hand, if the environment starts to become threatening or in some way altered, you will then send a signal and perhaps then activate the cancer in your own body. And we'll talk about this in a little bit, but in fact, even if you don't have a so-called cancer gene, the environmental signal can rewrite your genes and make a cancer gene. And all of a sudden it says, oh my God, then you really have to recognize that this biology that we look at is really a reflection of the environment, or at least how we see the environment. And this becomes important because of how about if we change our view of the environment? Oh, if we change how we perceive the environment, then we can change our biology. As fast as you can change your belief, you can change the biology. If you doubt that, consider multiple personality people. Each personality in the multiple, when that takes over the body, it actually instantaneously reprograms the body's physiology to represent the new consciousness that took over. It doesn't take but a couple of minutes or less to change things like eye color. You can have brown eyes in one personality and blue eyes in the other personality. As soon as that personality takes over, it reprograms the cell and changes the expression. Why is that important? Well, that's a pathology. But what it says is this. The value is, if you understand that, then you can change your beliefs and then change your body and genetics within minutes. And that's called spontaneous remission. When a person is riddled with cancer, those people, who are the ones that get spontaneous remission? The ones who change their mind about the disease, the ones who fight the doctor and say, I don't have that, and I don't want that, and I'm going to have a different life. You have to have the exercise of the control, and you can spontaneously go into remission and lose the cancer within minutes. And it's done because the cells are programmable. So basically, perception controls the behavior, perception controls the genes. Now, for today, here's some of the new stuff, and here's what I'm going to show you first. I said that biological processes employ Newtonian physics. Well, in Newtonian physics, the rule is very simply this, that the only thing that matters in the universe is matter, physical things. So in Newtonian physics, there's no energy. It's just physical things. It's you and me, and between us, there's nothing. And the problem with a world that's based on materialism is, what about the energy? Well, the fact is, conventional biology does not entertain the notion of energy because they're still in Newtonian mechanisms that don't recognize energy. So the relevance is, in all the medical textbooks, if you talk about, what about the energy changing the body? And, you know, complementary healers and other people out here in this New Age area talk to the medical doctor, and the medical doctor goes, what are you talking about? There's no energy. I went to medical school. We didn't learn energy. We learned matter. There's nothing in the textbooks about energy. Why? They're still locked in Newtonian mechanisms. And the problem, of course, is that we're not there anymore. And the reality is this, that to understand how something made out of matter, like a clock, works, you can take it apart and then look at all the pieces, and that's called reductionism. The idea that you can see the mechanism, take it apart and study each piece, and why that's important is if your clock mechanism, your body isn't working right, it would represent that some of the pieces are not right. Some of the parts are off. Well, then, what if I can make you new parts? If I can make you new parts, then I can control the running of your machine. So if you're being pathological or unhealthy, it suggests that some of your parts are not right. And if that's right, then what if I get new parts and give them to you called drugs? That's drugs. Those are physical parts. The drug companies manufacture parts to replace the gears in your body if they're defective. So the belief system is you're a machine made out of parts. All the individual parts can be understood. I can make new parts, and by making new parts, I can control your health. Well, that is the vision of the drug company. Something's wrong with you, we find new parts and sell them to you. Of course, the drug company is now so lethal that just last year in the United States alone, 120,000 people died of prescription drugs, compared to 5,000 people who died of illegal drugs. Now, we crucify anybody who deals with illegal drugs, but take in an agreement that we can kill 120,000 people. It makes no difference. Now, the issue about here, this is where the reductionism concept comes in. This is one of those antennas that's in the membrane that reads the environment. Conventional biology says this, that the antenna is made out of physical matter. Remember, everything is made out of matter. And the antenna responds to physical matter chemicals. The chemicals are drugs or hormones or things called neurotransmitter. And how do they work? That the chemical, like a lock and key, plugs onto the receptor, and that's how the receptor knows if the signal, the chemical, is there. If there's insulin, how do I know if there's insulin? Because the molecule has a shape, and the receptor for insulin has a shape, and the two come together like a puzzle piece and plug in, and therefore then the receptor can recognize the presence of insulin. But it's all based on the fact that they're chemicals. Now, this article was in Science, the mainstream prestigious journal in the United States today, just within the last 2 years. The point. But perhaps the biggest challenge to reductionism, the idea of taking it apart and studying the pieces, comes from the concept of information. Information. It says, in biology, and this is the point, I said, in biology, information is carried and received by molecules, which is fully consistent with the reductionist principles of physics and chemistry. What it says is, in biology, all information is molecules. So if your body is not working right and you want to provide it with correct information, then you take molecules, drugs, to correct the body. And this is the whole premise of conventional medicine. There's a neat little caveat at the bottom. There's a need to realize that information may be transmitted in ways that may be lost by studying molecules alone. Meaning, maybe there's other ways other than molecules for information. Well, the answer is this. In 1925, the concept that the universe was made out of matter, which is Newtonian, gave way to the new understanding in physics, which is now not new, 75 years old, that the world, the universe, is made out of energy. And that matter is a form of energy. And why this is relevant is it brings energy into the required equation of biology. You cannot understand biology if you don't understand the energy. Well, all of a sudden it says the energy is fundamental to understanding biology, and I ask you a question. How much energy is in conventional biology today in medicine? None. Well, that's why medicine has become so lethal. It is because they have not recognized that the primary aspect of control is the energy and not the physical universe. So remember the pictures in the textbooks of atoms? This is how we perceive an atom. But here's the truth. This is the quantum atom. Okay? And the issue about it is this. There is no solidity or physical structure to an atom. An atom is energy. And the significance of that, if the atom is energy, it responds to energy because it's made out of energy. And the bottom line is, biology is locked into this world of materialism, thinking that atom is made out of matter, and the reality is physicists show us that atoms are made out of energy. So therefore, science is 75 years antiquated by not recognizing this biomedical science. What does this change? Well, Newtonian mechanics says, study the material elements. Quantum physics says, study the energetic elements. That's a completely different point of view. Number two, Newtonian mechanisms say it's like a watch. I can study each little piece and see how they interact with each other to drive the mechanism. So I should be able to get awareness by just studying the little pieces. But quantum physics says, no, it's not reductionism. It's not looking down at the little pieces. It's holism. You have to consider everything in the field as contributing to what's going on, so that when you go to see a doctor, even though they focus on your physical body right here at the moment, your physical body is a reflection of what was going on in the environment. So without an understanding of the energy of what was going on in your life, the doctor is really lost by just looking at your physical reality. So the bottom line, that reductionism doesn't work. And one of the key hallmarks of quantum physics is called Heisenberg's principle of uncertainty. And it says this: you can never really determine how anything works because there are too many things that contribute. So the bottom line is, every foundational fundamental principle behind conventional medicine is negated by the role of quantum mechanics. So therefore, biology is out of step with the physical world, okay? And we're going to get through these molecules. Hold on, because we're going to get into your life, and that's more important, I know. But I need this because what this point I'm talking about is that it joins complementary medicine and conventional medicine and spirit all into one understanding when we add the energy back into the equation. I'm showing this slide not for the title on the top, but for the subtitle. If you can read the subtitle, it says, every atom or molecule emits and absorbs light of characteristic wavelengths. The point is this: every atom is vibrating energy and sending it off, and every atom is also receiving energy, so that the fields around the body are controlling the atoms of your own body. So therefore, even the invisible things you can't see have a profound effect on your life, because the energy is invisible, but yet it activates your molecules. To get an understanding of this, imagine the energy that comes off of an atom as ripples on a pond. So you remember, if you drop a pebble in the pond, you get ripples, okay? And the waves of the ripples actually represent the waves of energy that are radiating. Every atom is emitting light, which is energy, right? So what happens is this: the energy can interact with each other. So let me explain how. I drop a pebble in the water here, and the ripples start moving. So, imagine the ripples are moving through the water. And I drop a pebble over here, so the ripples are moving this way. So I have two sets of ripples coming together. The question is, what happens when the two ripples hit each other? And the answer is they add up. So the point about it is this: if I have two ripples of the same size, frequency, coming together, then I add them together, the energy of the ripples are twice as high as they were where they meet. And the reason for that is called constructive interference, meaning that if something is vibrating and something else is vibrating at the same frequency, they both will then vibrate faster and with greater power than before. On the other hand, here's this understanding. What if I drop a pebble in the water and the ripples start to go up and down, but I drop this other pebble, but it's not in phase, meaning when these ripples form, this ripple that I originally started with is on the way up, this ripple is on the way down. So as they start to come together, one is going down, the other is going up, one's going down, the other's going up. What happens when they meet? And the answer is they cancel each other out. Okay? And here's the point, if I can just relate this very quickly to you. You're vibrating at a frequency just like ripples. If you walk into a place that you've never been before, and all of a sudden you feel extra energy, why are you feeling extra energy? Because something out there is vibrating at the same resonance that you're vibrating at. We call that good vibes. What are good vibes? That means I feel really good. I've got more energy than I had before. And why? Because in the environment there are sources of energy that are the same as me, giving me extra energy. I'm responding to them. But on the other hand, haven't you been someplace, a dark alley, walking down the street, and all of a sudden you felt your energy disappear and go flat, and you feel, oh my God, I'm really weak, I lost my energy? Well, that's bad vibes. And what are bad vibes? This. You lose your energy and go flat. Why is this important? Every organism on this planet reads the vibration to know whether a signal is supporting it or whether a signal is threatening it. And these are given to us in the form of sensation. When you're in the right place, the energy is good and you get extra energy. So you know you're in a supportive place. But when you go to a place and you feel the energy get drained out, that is your body giving you a signal that you're in an environment that does not support who you are. And that bad vibes is the idea, get out of this environment. Predator-prey relationships, that the predator is reading the energy of the prey. And the prey can tell that that animal that's reading its energy is after it. Why? Because when the prey feels the energy, the prey goes, bad vibes, and then wants to get out of there. And the point about it is this. Language covers up these feelings. If we did not have a language, we would all respond to the vibrations. Shamans can read the vibrations from plants. So then they talk about the plants are talking to them. The plants are either increasing their energy or decreasing their energy. So the question is, they know about the role of the plant at that time, because if it increases the energy, this is a good plant. If it decreases the energy, it's a bad plant. It's the way animals know how to eat without going to school to learn what they should eat. Okay? So basically it goes like this. The tuning fork has a vibration. The goblet, remember, has atoms in the goblet, and the atoms have a vibration. What if I tuned the vibration to be the same vibration? What happens when two vibrations are the same and they come together? What happens to the collective vibration? They get much greater. Well, the shape of the goblet is due to the fact that all the atoms are locked into position. Even though they're vibrating, they're still locked into position. But if I hit the tuning fork, and it has the same vibration, and I absorb it, and I'm an atom, I start to swing more wildly, and the net result of that is what happens to the goblet? And the answer is, the goblet explodes. It doesn't break, it actually explodes, because the atoms are vibrating so fast they can't hold on to each other, and it lets go. Well, we're pretty much aware of this. This really goes on, but the question is this. What if I take one of my proteins, remember, with my antenna, and my antenna is vibrating at a certain frequency, and I get a tuning fork with the exact same frequency, what will happen to the antenna? It will either go fast, well, if it's the same frequency, it will go faster. If it's a cancellation frequency, it'll stop. And the point about it is this. Therefore, then, when I hit a tuning fork and the vibration hits the protein, it can change the shape of the protein, which is how the protein responds to the energy, whether it's a chemical or not. And the point is, therefore, then we anticipate that the receptors on the cell respond to energy equally well as they respond to chemicals. And why this is important is I don't even have to have the source of the energy nearby. I could have the energy far away and alter my biology, even though medicine doesn't look at it. And the question is, well, is it true? Does energy actually affect the body in any way whatsoever? In the references in the notes is this paper called Deciphering the Language of Cells, and he talks about electroconformation coupling, which means if the frequency of the energy matches the frequency of the molecules, then the molecules will respond. I bring this paper up because he worked with an enzyme, a protein in your body, that creates ATP. ATP is the fuel of the body. You operate your body using ATP as the fuel, just like gasoline. But you have to make ATP. And normally, we have to make ATP, we eat food, metabolize it, and use the energy from the metabolism to power the protein to make the ATP. What he shows is you can take these enzymes that make ATP, and if the electromagnetic field is right, the protein can trap the energy out of the field and make the energy for your body without metabolism. What does that mean? You can trap energy out of the field to power your own body. You don't need to eat food. The reality is we're down at a place where breatharians have been trying to tell us that, and the reality is this. Some food is very necessary, a small amount. Even breatharians eat a small amount. We've overdone it. We don't have to eat this much. In fact, here's the truth. If you cut back and go on a subsistence diet, a minimum subsistence diet, you can essentially live to a minimum of 150 years easily. The idea is every animal that has been shown where you regulate the diet and take it down to the minimal level, you can double the lifespan of the animal. And why this is important is because food is so abundant to us now with all our technology, we have to remember when we started on this planet, food was very scarce. We only ate minimal amounts of food. We were healthier then than when we made food so abundant, we start to get sick from eating the food. How do we get sick? You know, when you start your car up, you're burning gas and you give off carbon monoxide, the waste product. When you eat food and burn it as metabolism, you give rise to waste products called free radicals. The free radicals destroy the body. The more you eat, the more free radicals you have, the more you destroy the body. And the reality is, by cutting back on the metabolism, you then extend the length of the body because you have not destroyed it with the accumulation of free radicals. This has now been experimentally demonstrated, and they're finding that genes that can double the life of the organism, meaning if they knock out the gene, the animal's life can double. And they found out, well, what is this gene involved with? It's involved with metabolism. So basically, again, metabolism is the primary source of our early demise because we eat far more than what is necessary. Okay? Recently, and we're getting close to the end of the molecule stuff, so you'll feel good here, I hope. This is an article that came out in last October, and what it talks about is how does a protein actually really work? This is the first time that they got to the molecular core of where's the actual source of why the protein does its function. And the answer is, they conclude that electron transfer, that's the job of this protein, moving electrons, occurs through a web of tunneling pathways with constructive or destructive interference. Remember, constructive, destructive vibration? Constructive, destructive interference between pathways that is typical for the wave-like processes of quantum mechanics. The point is, this is the newest science that reveals that the underlying drive of why proteins work is the quantum field. And all of a sudden, all biologists that are not into physics are out of the picture. And the reality is medicine has no concept of this at all, that it's the field that drives the molecules. It's the energy that drives the molecules. Well, does it really work? And here's this thing I wanted to show you. I've just put some examples up. These are out of the most mainstream conventional scientific journals that exist. All these references are in your papers. Time-varying magnetic fields effect on DNA synthesis. It shows by changing the magnetic fields around cells, I can turn on DNA synthesis or I can turn off DNA synthesis. Number two, pulsing electromagnetic fields induce cellular transcription. That means RNA synthesis. So again, same thing. I can turn on RNA synthesis on or off by regulating the electromagnetic field. The last one, exposure of salivary gland cells to low-frequency electromagnetic field alters polypeptide synthesis. That means protein synthesis. What's the point? The main things that cells can do, DNA synthesis, RNA synthesis, and protein syntheses, are all controllable by the electromagnetic field. And these are in mainstream journals, scientific, hardcore biomedical journals. And the question is this, how come there's so many articles, and there are hundreds of these articles, and yet it's not in any textbook? We never talk about the role of electromagnetic fields in a textbook. Again, It's the blinders that biomedicine has against energy, which is really the blinders provided by the drug companies, because the drug companies sell drugs, they don't want to distribute energy, and therefore they deny the role of energy. And when all the grants are put out, if you try to talk about energy, you won't get funded. You won't get funded because conventional belief is molecules, not energy. So the point is, what I'm saying is not that energy affects things, that it's not just I'm saying that the literature tells us consistently that electromagnetic fields can alter mitosis, that means mitogenesis. In other words, in the right electromagnetic fields, these white blood cells called mononuclear cells, if you put in the right electromagnetic field, you can cause them to divide even though they weren't supposed to divide. So in other words, what is this relevant to? And the answer is leukemia is due to the proliferation of these mononuclear cells. What it says is the electromagnetic field can cause their proliferation, which would be seen as leukemia. And the bottom line, does electromagnetic fields affect your body? The answer is yes. In the literature, what about it? And the answer originally was the studies that were first carried out were carried out by the Electric Power Institute to see if electric power influences the body. The answer they came up with was no, which was not surprising because that's the Electric Power Institute. The bottom line is when all the data was reviewed, the answer was yes, it does affect us. So they've reopened this understanding to show you that the fields around you can alter your biology in every degree. I've only given you some. One of them that's really important is that it causes hormones to be affected in your body, especially estrogen. Electromagnetic fields, biological influences, fields exert effects on and through hormones. Estrogen is one of the primary hormones that's been shown to be affected by the electromagnetic field. Estrogen is involved with cell proliferation and structure and cancer. And so the bottom line is this. Do the fields affect the biology? The answer is yes, whether the textbooks want to say so or not. And so we really have to get to this understanding is that does everybody get affected by the field? And this is what I want to tell you because this is the important point. When they do the study, they find, look, a lot of people are not affected by the high power lines. Look, they're living right under them. They have no effect, and this other family has an effect. They now have found this. The effect that electromagnetic fields have on an individual is related to the stress the person is experiencing. If you're not under stress, the body is immune to the effect of the field. When you're under stress, you are open to the effect of the field. So this all of a sudden says, again, you can live in the field and not have a problem, but then you also have to make sure you're not under stress when you're living in the field. So basically, it's not the field that really is the source of the problem, it's the stress that's the source of the problem. Okay? Now I want to show you this device. This is an ancient picture of what is a very modern device in a hospital today. It's called a magnetoencephalograph, MEG. You are familiar with EEGs, right? They put wires on your head and test your brain activity. Well, that's not very effective. There's a better way, and this is called a magnetoencephalograph. What it's reading is that when you're doing neurological processing, not only is electrical activity coming around your head, but magnetic fields. There's a magnetic storm all around your head. You're broadcasting a magnetic field that is linked to your conscious processing. And it's not strange or weird. It's basically a simple phenomenon of physics. Under the skull, the nerves in your head are like wires sending electrical information. Well, if you take basic physics, it says this is what's called the rule of the right-hand thumb. It says if you have a wire and a current is running from, let's say, here to here, if you take your right hand, put the thumb facing the direction of the current flow, and wrap your fingers around the wire, the fingers will mark the polarity of a magnetic field that is around the wire. And the reality is this. The nerves are sending electric activity down them, but these big orange loop, which is the rule of the right-hand thumb wrapped around it, the magnetic fields exit the head. The relevance is your thoughts are not contained in your head. Your thoughts are manifesting a field. The field can affect your cells. So there's one direct connection right there. That whatever I'm thinking, I'm creating a field that my cells are going to then follow my thought processes in this direction. And that's where the power of the mind comes into this, is that we're generating these fields. Now here's the interesting thing. If energy is coming out from thinking, what if I throw energy back in while you're processing information? Anybody hear of Michael Persinger from Canada? A long time ago, he developed a little helmet that he says when you put on this helmet and turn on the voltage and shoots electricity in your head, you can start to get hallucinations. Well, that was a number of years ago, and now today's current modern science, this is just this year, talks about what are called transcranial magnetic stimulation. What it is they put a cap, just like Persinger said, over your head, and they can send current back in your head. And the reality is this. They have a person look at some vertical bars going up and down, and then they turn on the current. And while they're looking at the vertical bars going up and down, all of a sudden the bars start to go wavy and hallucinations start to appear in the field. And the reality is, then your thought processes and your consciousness can be altered by the fields coming into your head as well as the fields leaving your head. And so the important part that was really neat about this study was this. Not only did, when they put the cap on, while the person was actually looking at the vertical bars where the bars distorted, they tried this. They got rid of the bars and they said to the person, close your eyes. Imagine you see the vertical bars. So they recall the vertical bars, and they push the button, and then right then the vertical bars undergo hallucination. So they even cause hallucination of something you're imagining that's not even real. So the bottom line is the electromagnetic fields profoundly alter your neurological processing. Well, this is relevant because, as Dr. Goswami, who was here at the conference, wonderful, wonderful work that he showed is this. Everybody is radiating energy from your heads, right? And that people can entrain with each other. And the relevance of that is, in physics, there's an understanding, which is Einstein, Podolsky, Rosen, that says, in the universe, particles can be complementary. They can come in pairs. One particle will spin clockwise. The other particle, the complementary particle, will spin counterclockwise. And then it shows that if you take the one that's spinning clockwise and reverse it, the other one will instantaneously reverse because to keep the complementarity, if one is spinning clockwise, the other has to spin counterclockwise. Well, the point about this is how far apart can you move the particles and switch one and cause the other one to switch? And the answer is you can apparently move them to one end of the universe to the other end of the universe, separate the particles, and here's the blow-away part of it. If I flip this particle, the other one will instantaneously flip, and guess what? Faster than the speed of light, because the distances are much greater than the time. So all of a sudden it says, my God, there's another understanding. We're all interconnected in this other realm. So what did Goswami show is that he took a person, had two people get bonded together, bringing them together so they're sharing wavelengths, and then put one in a Faraday cage, which is a wire cage to prevent electromagnetic fields from making an effect. Put the other one 50 feet away in another Faraday cage. They were coupled by their coming together and bonding. But now they're physically separated by 50 feet. They take the one guy and they put a light and flash it in his eye, and you get a neurological response called an evoked potential. And the interesting part is, while they were shining it in that guy's eyes down there, when that person got the evoked potential, instantaneously the person they were bonded with got the evoked potential even though they didn't see the light. And the relevance is people bond with each other, and as a result of that bonding then become connected through the atmosphere simultaneously, so there's no time delay in this process, so that we retain connections with each other when we start making bonds, bringing community together. This is relevant to all of us who know that when you get close to your partner in life, that you get close enough that you actually can communicate to each other without most of the words involved, because if there's an outsider or bystander listening to the conversation, it's like, what the hell are you guys talking about? There's like, you're missing most of the nouns and verbs in your sentences. Do you want to go? Yeah, I go. You know what time? It's like, okay. And the bottom line is this. Why? Because once you get closer to people, you entrain to the frequencies, the bonding gets closer, you become more complementary, and so that you can communicate over these long distances. We're all connected. You all are familiar with this. You all have had experiences with this. This is interesting work by Amit Goswami. Okay? Now, this part I want to really get into because this is our change of pace. All of us are different. We know this because if I try to take cells out of your body and put them into somebody else's body, what happens when I put the cells in the other person's body? They get rejected. Why? Because they're not self. We each have a self. Every individual is unique on this planet. Each one has a unique self. And the question is, where is the self? If we could understand that, then we could really get to the identity of who we really are. So I want to show you something. I take two cells, Bruce's liver cell and Margaret's liver cell. Why I picked the same cell type is this. The cells are carrying out the same function, so most of the stuff in the cell are exactly the same between the two cells. But I tell you this, what if I remove the color from the slide of everything that's the same? What would I be left with by by obvious deduction. Whatever is the difference. So what I'm going to do now, watch this. I'm going to remove the color from everything that's the same, and what you're going to see left over is where the differences of self lie. Where's the color?
Cell membrane.
Outside. It's on the outside. It's the antennas. We have different antennas on our cell, so our cells are like television sets receiving a broadcast. These receptors are scientifically called self-receptors. Well, that's pretty obvious. Receivers of self. Why is this relevant? Well, if I wanted to put my cells into Margaret's body, these self-receptors will be recognized by Margaret's immune system saying, that's not me. So what can I do? How about if I take an enzyme and cut off my self-receptors so my cell doesn't have self-receptors on? Then what's the identity of my cell? And the answer is generic. It doesn't have any identity. That's why I can take my cell and put it into Margaret, or I could put it into a mouse, or I could even put it into a chicken. It will never be rejected because it's just called cell, not Bruce's cell anymore. Now here's this other interesting concept. If I take my cell, and it's mine, why? Because I have my antennas on the surface, right? And if I take my antennas off, who's the identity of the cell? Generic. It's generic. Now I take Margaret's receptors and borrow them from her cell and put them on my cell. Whose identity is this cell? Margaret's. I transfer the identity by transferring the receptors. Now here's the beautiful part. The receptors are not the identity. The receptors are the antennas for the identity. Where is the identity to be found? And the answer is, the identity is off in the environment. It's the self is outside. The self plays through the antennas. Therefore, in the moment that I started to recognize this understanding, the first thing I said is, I cannot die. Why? I'm not even in here. Where am I? I am out here. I am a broadcast. I'm an environmental energy that is being picked up by my cells and then playing me through this physical body. And the relevance of this is very important because it also leads us to the solution of survival on this planet. We're always talking about somebody coming, a messiah, white light, or whatever the heck it is. Let me explain what these receptors are and give you a better picture of who you are. If I take white light and run it through a prism, what happens to the white light? I break it up into the rainbow of colors. If I can separate every individual unique color out of that, I can get billions of separations, each one a unique frequency. So for example, let's say we're on a stage and I have spotlights on the stage and I have a green and a red and a yellow. And I say, these are identities, these are egos. Each color has its own unique identity and character to it. But I say, where did the color come from? And they say, well, there's the spotlights up there in the ceiling. Let's go up there. So I look at the spotlight and I see in the front what's called the gel. I pull out this filter. When I pull out the filter, what's the color on the screen? White. When you remove your self-identity from your receptors, you're in tune with the white light. When you put the filter back in, you're in tune with only the frequency that's your particular identity. Why these are important? Each one of us are a little fraction of color out of the white light spectrum. If you want to understand when the white light comes back to the planet, is when every human being is recognized that they are a frequency of the white light, for the simple reason is this. If I split the white light up in break it up into the color patterns and remove any one frequency, no matter how small it is, do I have white light left or not?
No.
No. You have to have every frequency to make white light. The lesson for us is to understand every human on this planet is a piece of the white light, and the moment you eliminate any frequency from the white light, any individual from the community, you no longer have white light on the planet. And obviously we're very far away from that understanding. Okay, now let's get personal down here and see what this is all about. And what I didn't get a chance to tell you, because they don't give me enough hours right here, is that every cell, and this is a truth, and you'll see it in the course book if you look at it because it's more spelled out in there, every cell is a programmable computer chip. Every cell has, the chip is a cell membrane, the keyboard are the receptors. The receptors are like keys on a typewriter or on a computer. When you push the key, you're entering data. Every receptor is a receiver of data. So the surface of the cell is a keyboard, and the nucleus of the cell is the disk with all the programs. So every cell in your body with a nucleus has a complete range of programs to become an entire human. So a skin cell has the entire range to become the whole human again. That's how cloning can occur, okay? Because every program to make a human is in every cell. Which programs you select are exactly the way you use a computer. The program you selected, you push the key, you pull up the program. So the programs that we play are really based on what's pushing the keys. Well, where are the keys? On the surface of the cell. Who's typing on it? The environment. So the environment is calling it up. But the question is, what kind of programs are in the system? Now, this is health-oriented right from this point on, and specific to you for this reason. What are the kinds of gene programs that are in the physical body? I'm going to tell you right now, I can subdivide the programs of all the genes you have into two classes of programs. The first class, both classes of programs are what enable you to survive. In biological imperative, we call it the will to survive. We don't understand it biologically, but it's this. No matter what organism, a human, a mouse, or a bacterium, if you threaten the life of an organism, it will take any action it can to stay alive. Where's the drive that does this? Why does a bacteria actually want to stay alive? It's built into the gene programs. Let me explain the two classes of programs. Class number one. The major number of gene programs in your body are for growth and reproduction. Relevance, the growth keeps you alive, and reproduction keeps the species alive. So you need both sets, growth and reproduction. Here's the other thing. The growth programs are all your metabolism, your physical body construction, etc. And the important part about this, and listen, growth goes on in your body every day. If growth does not go on in your body, you lose like trillions of cells and your blood and all kinds of tissues every day. What you have to do is replace them. What would happen if you can't replace the cells? Then you express disease and pathology. So the issue is this. No matter what age you are growing every day to replace the stuff that you lose every day, or if you need to increase something, you can exercise it and it will grow faster. So basically, growth is really not just for kids growing up, it's for us to the day we die. Right up to the day we die, we are growing every day. But in addition to growth and reproduction, we need one other set of genes, a type of gene function to keep us alive other than growth. And the answer for these other programs? Protection. Protection and growth are not the same thing. Protection doesn't add growth or mass to your body. Protection is, in fact, in contrast to growth. Growth and protection are actually, at the cellular level, mutually exclusive. I'll explain why. But the bottom line is this. Does it take energy to grow? Yes or no? Does it take energy to protect yourself? Oh, then this is the point. You have a budget of energy, like a checkbook. And every time you exercise a function, you use energy. Well, the fact is, if you start getting in a lot of protection, what happens to your energy budget? It goes down and down and down. The more protection you're in, the less growth you can do. Simple fact. So the bottom line is, survival is actually equal to growth divided by protection. The more protection you think you need, the more you shut off the growth. But why should that be so? Well, let's explain it this way. On the top, I show a petri dish with a single cell in it. On the left-hand side, I say, what if I added some nutrients to the culture dish? What's the cell going to do over time? So I put the nutrients in the culture dish. I come back in a few minutes. Where do you think the cell is going to be? It's going to move toward the food, right? But I do the experiment again, but on the right-hand side, instead of putting nutrients in, I put toxins in. When I come back later, where's the cell going to be? Is it going to move to the toxins? No, it's going to move the other way to save itself. Here's the point. Organisms move towards signals that give them growth and move away from signals that threaten their existence. The point about it is this. The cells move forward in growth, backwards in protection. You got it? Well, the point is, can a cell move forwards and backwards at exactly the same time? No! And why that's important is that if I provide a growth environment, the cell is sure going to grow. But if I provide a protection requiring environment, the cell will back up and shut off its growth processes as it's protecting itself. The point is, cells are digital. They're either in growth or they're in protection, but they cannot be in growth and protection at the same time. Oh, well, this becomes relevant when we start to understand then that the behavior of an organism is that it always moves toward positive life-supporting signals, and that's the growth part. It then always moves away from, repulsed by signals that threaten its existence, and yet I also have to say there are some signals that make no difference to the cell. The cell can read it, but it doesn't necessarily make it grow or protect itself. So the three movements, that's all the cell can do. They observe the behavior. All it can do is either move towards something, move away from something, or not respond at all. And the important part about that is growth is always a movement forwards. Protection is always a movement away. You protect yourself, you sink deeper into yourself. Why is this relevant? The cell, like your human body, your body is actually an image of the cell, even though it doesn't look like it to you, but I could give you a cell biology course and you'd understand it. And basically it's this. There's a region of the cell where all the organelles are. This region right here, where all like the nucleus and mitochondria, all those things that are organs in the cell, like your organs. Where are your organs located? They're all in this area right here. This is the equivalent of the viscera. The cell has a viscera. But then the cell has around the periphery in red the bones and connective tissue and the myosin and actin and for muscle. And the point about it is this. Then I have two parts of my body. A viscera, which is involved with growth, and this system, which is involved with support and protection. And the point is, one can be in charge of the other depending on what the environmental conditions are. So I'll give you an example. My visceral system says, Bruce, you need some water. Well, although the visceral system says it, how does the visceral system get water? It tells my somatic system, my arms and legs, okay, go get some water. So it sends me to go get water. So this, in the case of growth, the viscera tells the somatic system what to do. So on the way to go and get water, I stop and I see a lion in front of me. And as soon as I see the lion, it's like, the hell with the water at this moment, And in fact, is a lion a positive or a negative signal? Negative, so am I going to move toward the lion? No, I'm going to run away from the lion. So I start to run away, and I forget the concept of water because now I'm in protection. I'm not in growth. And the moment I'm in protection, my somatic system overrides the viscera. Remember that old story about not going swimming after you eat lunch? Why? Because when you eat lunch, you put all the blood to go into growth. Then you go out swimming. Where's the blood needed for swimming? Not in the viscera, in the body. So you pull the blood out of the digestion process in the middle of it, and that's where the cramps and all those other issues come in. Why? You're either going to be exercising your somatic system or you're exercising your visceral system, but one rides over the other. Why is this relevant? Because humans are like cells, but not so digital, because we have 50 trillion cells. What percentage of my cells are in growth? What percentage are in protection? Gives me a sliding scale. So the bottom line is, humans have plus and negative over like a ruler. And here's the truth. Love is the greatest nutrient of the human body. And you know it. You might want to go out and get a steak dinner or a vegetarian dinner if you're hungry, but if love is there, it will supersede anything in your life. Why? Love is the optimum growth signal. You will not only go over the mountain to get to love, if necessary, you will go through the mountain to get to love. And the bottom line is this, while love is the ultimate growth system, fear is the ultimate protection. When we're in fear, we shut down our growth processes. And when we do that, we then stymie the maintenance and health of our human bodies. The relevance of love as an important factor is this. Children, especially in orphanages in Eastern Europe where there's so many children and not enough caretakers, the children get no attention, no handling, and no love. And the reality is they show a decline of every aspect of every parameter of their health. The physical nature of their body, their intelligence, their general nature of their health and pathology are all related to the amount of love. You can reduce the size of the body 30% by not providing love. That's basically what they showed. That children become autistic when they don't get love. Why? Think why a child, what is autism? Autism is not communicating with the environment. That's as far deep as you can get in your body to separate yourself from the environment in protection as you can get. You get so retracted in protection, you don't even touch the environment on the outside. People who are in lack of love will end up going in that direction of going inward so deep they won't communicate. What's in the bar? The question is, what's in the bar of my slide right here? And the answer is this. I said in the cell slide, it was growth or protection. In this slide, I'm saying it's like a ruler. There's a gradient of you can be not in full love. You can be in less than full love and still grow, okay? So the bottom line is humans are not either or, but are in some various stage, some percentage of growth or some percentage of love.
And is it the measurement of the coherence of the cells?
Well, okay, the question is it the measurement of the coherence of the cell? And the answer is this. Yes, for this reason. When the cells are coherent, that is full growth. When the cells are in dissonance, that means they're separating from each other. That is full protection. So you're getting a gradient of coherence, okay? Now, the bottom line is, I showed you in the cell that the cell is either in growth or protection. Let me show you that the human is in growth or protection based on the signals. And here's the system that controls it. It's called the hypothalamic pituitary adrenal axis, HPA axis. The relevance is this. You all went to school and heard about the adrenal system. What's the common name for the adrenal system? Fight or flight. What is fight or flight? That's protection, okay? Well, here's how it works. The hypothalamus, the region of the brain, is what scores the signals that come from the environment as plus or negative. And as the body is scoring all the signals, if there's more negative signals than positive signals, then the body will say, I need to protect myself. And so what it's going to do is the hypothalamus, which is reading the signals, sends information to the pituitary. Remember in school, what is the common name of the pituitary gland? The master gland. Why? Because it controls the expression of the rest of the system. So what happens is the pituitary sends a signal down to the adrenal glands. So we go from the hypothalamus to the pituitary, that's the H, hypothalamus to pituitary P, to the adrenal glands A, HPA. And the adrenal glands release the adrenal hormones. Now, what is the function of the adrenal hormones? What was it, growth or protection?
Protection.
Okay, now the issue is this. Do you protect yourself with your lungs or your kidney, or you protect yourself with your arms and your legs?
And running.
Okay, so the idea is this. When a protection response comes in, the hormones, the adrenal hormones, shut the blood vessels off in the viscera to push the blood to the periphery where the blood is needed for running or kicking or fighting. Well, wait a second. If the blood is shut down in the viscera, what happens to the function of the viscera when I'm shutting down the blood? It diminishes. The first thing I'm trying to tell you is even in your human body, the moment you're under stress, what happens to your visceral functions? They get shut down. But these are growth mechanisms. And I'm sending the blood to get ready to run, fight or flight. Okay? So I'm physically shutting down growth in anticipation of protection. Now the next thing is this. When I'm under stress and I now have shut down or decreased my viscera functions to get ready to run and fight, I ask you a question. If I'm under stress from my adrenal system, it's because something in the environment is threatening me. If something in the external environment is threatening me, will I deal with it using my immune system, yes or no? No, the immune system is protection, but only protection of things that are on the inside. So if the signals come from the body that my threat is outside, then should I use my immune system, yes or no? No, and the answer is because the immune system uses so much of your body's energy that when you get stressed, the same hormones, the same corticoid hormones that are released that cause the blood to go from the viscera to the periphery, the same hormones shut off the immune system. And matter of fact, medical doctors use these stress hormones to shut off the immune system in patients who receive grafts and donor tissue. Why? Because those hormones shut off the immune system. Well, now what we just said happens to your body. Two things we just said. You get stressed. What about your growth mechanism? It's shut down. What about your immune system? It's shut down. So now not only are you under stress from the outside, but now you're opening your inside to be taken over by whatever might be there. Now, let's add a little insult to the injury. And it goes like this. In a fight or flight response, think about this. In a fight or flight response, would I use conscious processing to know what I'm going to do, or would I do reflex behavior? Okay, why is this important? Reflex behavior is the hindbrain function. Conscious thinking is the forebrain function. Point. These very same hormones, when they reach the brain, squeeze the blood vessels in the forebrain to push the blood to the hindbrain to exercise reflex behavior. What about your intelligence when that happens? It goes down. And most of you at any time have been like what's called exam stress. You get into the exam, you think you studied everything, you think you know everything. You hit one question that, my God, I didn't study this. And all of a sudden the fear, and you're sitting there in the seat, you know what you can feel? The blood starts leaving the viscera, and you start feeling tingly, you're getting nervous, and you know what? you can't think of the answer not just to that question, but you can't think of the answers to the other questions that you already knew. Why? Because when you're in a state of stress, you shut down your awareness. Well, the point about it is, cool if it's an acute response, but what if we're under stress chronically? Well, the answer is when you're under stress chronically, you're less intelligent, you're more likely to get sick because your immune system is shut off, and you're going to find pathology because you've shut down the nutrition and growth of the body under that chronic stress. So all of a sudden you start to see the debilitating effects of the stress, which is the primary problem on this entire planet, the stress. And then when we get this fight or flight response, we do all those things, shutting down the viscera, shutting down the immune system, and shutting down intelligence by changing the flow of blood and the control that it has. Okay? Now, here's the issue. I said that the environment, and this is really cool, so watch this. I said that the environment, I showed you how the environment switches the behavior, and I also showed you if you don't have the right proteins to carry out the behavior, the environment will select the gene so I can make those proteins. Now here's the question. What if I get a stress in the environment that I don't even have a gene to handle that stress? I'm in deep trouble here now because it's like, well, what am I going to activate to do this? Well, the only thing you can think about doing is changing the genes to accommodate the stress. But there's a conventional viewpoint about changing the genes, and this has an assumption, the third assumption. Darwinian evolution provides for biological diversity. Why I bring this up is the conventional information written in the textbooks is this, is that when you change genes, the only way they change, and this is in the book, the only way genes change are through random mutations, meaning this. I can cause a mutation by giving somebody a chemical or shining ultraviolet light on their cells. I can cause that mutation, but I can't control the outcome. The outcome of a mutation is random. Who knows what's going to happen? And that is the foundation of Darwinian theory. It says, how did we get here? Well, animals mated, and then there were mutations that were random, and it changed the body over time accidentally, and we ended up on this planet as a matter of accident. That is the foundational belief of Darwinian theory. But the answer to this is it true? And the answer is absolutely not. And in fact, if we look at the belief system, this is taken out of a paper, it's Thaler's paper, it's marked in the notes. Organisms, this was published in the journal Science, and it was a chart showing, here's our conventional belief. This is convention. Organisms at the top mature, and then they mate. So take two dogs, two organisms, they mate. The variations that they get are changes in the genes during the reproduction process. And so that when you look at the litter of puppies, they're all variants. You've got the runt of the litter on one side, you've got the bulldog of the litter on the other side, you've got a range of variation. Then, when the puppies have to grow up and leave the nest and fend for themselves and find their own food, the runt generally can't make it. The bulldog is stronger. It can make it. And what it says is nature will select the strongest ones, the bulldog, to mature and go up and mate. But the runt can't make it, so nature will select against the runt, and those bad genes are knocked out of the population. This is conventional Darwinian theory. 2 steps, variations by random mutation, followed by natural selection. Now, this paper came out in 1988. I want you to get the year on it. 1988 in the journal Nature. It would not have been published if it was not for the fact that the primary author, John Cairns, was one of the most prominent geneticists in England at the time. They published the paper, and I'm going to show you, they also wrote editorials right in the journal following the paper that they do not believe the results, but John Cairns is, he's a real guy, and they published the paper. And what did John Cairns talk about? Here's what he did. He took bacteria that had a mutated enzyme, an enzyme that doesn't work. The enzyme is specifically a protein that breaks down the milk sugar lactose. And the reason why he chose this is, what if he takes the bacteria that can't use the lactose and he puts them in a petri dish and the only food he gives them is lactose? So the bacteria are in an environment that even though there's all food there, to them it's like the Gobi Desert. To them there's no food because they can't eat the lactose. Why? Because the enzyme is broken. According to Darwinian theory, when can you mutate the enzyme? During the reproduction phase when you're copying the gene. Maybe you can then copy it differently and make mutations. Well, the question is this. If I put these bacteria that can't use the lactose into a petri dish with lactose, can they divide? Yes or no? No, the reason why they can't divide, they can't get the energy, they can't get the metabolism, the building blocks, they got no resources. And yet, within 3 days, all the Petri plates have colonies growing on them. Something completely unheard of and not even understood. The cells mutated not during the dividing period, they mutated in the resting period. And they mutated to adapt so they could adapt to the environment. Therefore, he called these mutations adaptive mutations, where the environment directs the outcome of the mutation. And it showed that it wasn't an accident, that the mutations were not random, in the sense that when they looked at the genes of the bacteria, not everything was randomly mutated like a shotgun, mutating everything until something worked. The only genes that were mutated were the genes related to lactose metabolism. The point, the most primitive organism on this planet will change its genes so selectively that it will specifically pick which gene has to be changed to accommodate the stress. No randomness to this process. The result, of course, is right after he wrote this paper, which was published in Nature in 1988, the editors of the journal Nature had an editorial. And the title of the editorial, British Sense of Humor, and it was A Unicorn in the Garden. Meaning that the Garden of Eden and the unicorn is a fantasy, that John Cairns' work is a fantasy, that his interpretation must be off. They said, we don't know what it is, but he can't be right. The Americans, much less sense of humor. The week after he wrote this article in Nature, this editorial came out in Science. A heresy in evolutionary biology. A heresy, of course, is a religious term which only tells you the religious nature of conventional biology. That they had a belief system, and it talks about in their belief system that mutations are a random process. The concept that a mutation is not random, anything more heretical can hardly be imagined. That was in 1988. Now I want to show this, and I'm going to use my theatrics to read it. This is an article in Scientific American in 1997. Remember, the article came out in 1988. Evolution evolving. This is my Shakespeare. New findings suggest mutation is more complicated than anyone thought. First line, 9 years ago, John Cairns. The point is, new findings 9 years ago. And the point about this article, which is really unbelievable, after 9 years where other people began to demonstrate that Cairns was right, they write this article saying, well, they see that a large number of people are showing this, but there's still got to be another explanation. And why should this be so? The answer is this. If Cairns is right, Darwin is wrong. That evolution was not random. That evolution was determined by the environment. That as we evolved, we were shaped by the environment. We were created in the form of a complement to the environment. Evolution is partially evolution and creationism coming together at the same time. There was the stepwise increase in the structure of the organisms, but it was matching a stepwise increase in the complexity of the environment. That we are coded by the environment. I see their urgency. Let's make...
10-second comment. Darwin, in Origin of Species and Descent of Man, said that natural selection was one of several factors
Right.
that determined the descent of species. It was Darwin's successors under the influence of capitalism that made it a very mechanistic and exclusive metaphor. Stephen Jay Gould and the whole company. But just in Darwin's defense, he said it was one of several.
I agree with you. When Darwin died...
Legacy got very narrowly challenged.
Okay, let me just sum up what you're saying and agree with you. When Darwin died, he actually had changed his mind several times in the process, and on his deathbed, he actually embraced the concept of evolution as supported by Lamarck, which was more environmental control. But by then, his ideas were more powerful than him, and they carried on even though.
Herbert Spencer, Thomas Huxley.
Okay, we'll go on that, but it was Darwinian theory that is wrong. Conventional neo-Darwinian theory. Okay, so let me just go on with this point, because here's the point about this. Therefore, then, we've also found, and this is a very recent paper, this was just last summer, or actually 2 summers ago. They took bacteria and split them into 5 test tubes, the same culture, and put them in 5 different test tubes, and then put in those cultures a stressful environment, the same stressful environment in 5 cultures, causing them to induce a change in the bacteria. After thousands of generations, they found that all the bacteria adapted in the same way. that no matter what happened, it says that these miniature adaptive radiations unfold in the same way every time, governed by the available environmental niches. The point of this research says that the evolution process was not random. The outcome was already determined. As soon as you set up the environment, the outcome was determined. Well, the point about that is, as we alter our environment, we alter our genetic expression to accommodate the environment, or our perception of the environment, okay? So when I go back to, this is Thaler, that article by Thaler out of Science. I showed you organisms go to variations, go to selection. This is what he said is the old belief system. He then put the next chart in, which shows the new belief system. I want to point it out here because in the next chart, I'm going to have organisms on the top, selection on the bottom, but I'm going to show you that there are 3 kinds of variations that are indicated. So you'll see 3 boxes on the right. So when I look at it, organism, selection, and these are the variations. Phenotype, that's your physical expression as you see it. This box says genotype, that's the genetic code underlying your physical expression. And this box, which now has a current new name to it, was called genes of DNA metabolism. They're now recognized as genetic engineering genes. What this says is that in your cells, you have genes whose function it is to rewrite the other genes if you're under a stressful situation. But the question that's really most important about all this is, what are these? These are 2 new boxes that conventional biology never had in the chart. What are they? The environment and organisms' perception of the environment. As what? Influencing, if you see the arrows, I lined this one in red. The environment can cause the genetic engineering genes to rewrite themselves and change the genetic code. The perception can do what? Change the genetic engineering genes and write the code and change your physical body. The whole point about this is, where we believed all these were random processes from within, we now recognize that they're directed processes controlled from without. That we are controlled to adapt to the environment in this particular case. And the relevance, of course, now is this most important part. Your belief system can rewrite your genes. And why that's important, for example, in cancer, less than 5% of cancer patients have hereditarily carried bad genes, supposedly, into their life. 95% or more of cancer people change the genes they have and make them cancerous. We used to always say all these changes were random. But now we're beginning to recognize, no, we are actively involved with changing our physical structure to meet what we perceive in the environment. And I'll give you a possible scenario. If you live in a patriarchal authority and you're female, you have a troublesome time here, as you all well know. And so the bottom line is this. If you find that the environment is male-oriented and you're getting angry and upset because you beat your head against the wall of being a female in this environment, what do you think you would try to do to compensate for your perception of the environment? Not be a female anymore. And how can you do that? Cut out your reproductive organs through changing your genes and eliminate them. And then all of a sudden you see the anger of the world generating very specific physiological consequences. Louise Hay's book, You Can Heal Your Life, will actually link how these perceptions and emotions specifically hit different parts of the body and change the phenotype, the physical, or the genotype, change the genes of the body in response to that. So it becomes relevant to understand that the environment is continuously shaping who we are, and it's a dynamic consequence. Now, so therefore, perception also rewrites genes. So when I put all the conclusions together, I'm going to just show you this last one. I talked about perception before. I'll show you the summary, but I'll just say it right now. Perception controls behavior. Perceptions turn on and off the genes, and perception can rewrite the existing genes. Perception is a primary control of the system, okay? But can I make new receptors? How do I rewrite genes to make a new receptor? Is this something novel? The answer is no. This happens every day in your body. Every day you have cells that are evolving, making new genes in response to the environment. These cells, the immune system. How does it work? Well, I start with some stem cells, which are parent cells, and I'll take this stem cell on top and divide it into 2 cells, the orange one and the yellow one. These are 2 daughter cells. What's different between them? In the orange one, I activate gene 1, the gene that makes a protein, this cup shape on the surface of the cell. In the yellow cell, I activate gene 2 that makes this Y-shaped protein. It's a different gene. Okay, these are two immature immune cells. They start to migrate through the body, and in the process, they encounter an invasive virus. The virus has this shape to it. Which cell is going to recognize the virus? Well, obviously, it's whatever one has the correct shape receptor. Well, the round one can't really fit that shape, but the yellow one can. So the yellow cell holds on to this virus, but it's not a perfect fit. It's just a temporary fit. In the process of 3 days, that's all it takes, the virus on the outside interacts with the genes on the inside. The virus never got inside the cell. The cell adapts the gene on the inside to match the virus on the outside. After 3 days, I've rewritten the gene to make a perfect receptor that will perfectly recognize this virus. This gene did not exist in the cell 3 days ago. The point about it is, this is the fundamental mechanism of learning and memory, whether it's in the immune system or in the brain. The cells respond to the environment and make receptors that read the environment and can tailor them to whatever they are. So even if I make a chemical that's never been in the universe before, synthesize this chemical and inject it into your body, generally within 3 days, you will have a new gene that will make a protein to know that new chemical. So basically, the cells are continuously adapting to do this. And when this cell divides, the one that made the new gene, when it divides, it will pass the new gene on to all of its daughter cells. So the point is, not only is it learning, but it has memory to pass the new information on. This is an evolution process. Your immune system is living evolution in your body. So, the conclusion, perception controls behavior, perception controls gene, and perception rewrites genes. Perception is everything. Now here comes my pet project about the whole thing. This article came out in 1999 in Newsweek. Where health begins. Obesity, cancer, heart attacks, how your odds are set in the womb. Here's the point. It has been traditional belief that when a sperm and egg come together, the fate of the child is determined from that point on. It's just a matter of unfolding the genetics. We now know that this is not true. Some traits are selected, eye color, hair color, height. But all the other traits in regard to behavior and how you express it are dynamically selected in the process of development. The reason why? What controls the expression of genes? Perception. Okay? Where's the baby growing? Well, it's growing inside the uterus. Conventional thought. This is conventional thought. If a woman goes to OBGYN checkup or prenatal checkup, what is the doctor concerned about? Are you giving the baby appropriate nutrients? That's basically all they're concerned about. Why? Because the belief is the control for the development is already inside. It's automatic. It's not even dependent upon you. All you have to do is feed the baby. That is the role of the mother. And therefore, in the medical checkup, all they're checking on is whether you're feeding them and you're healthy yourself to support the growth. But the reality is this. The environment controls the genetics. The fetal environment controls the expression of the genes in the fetus. But the fetal environment is the mother's environment. So the mother's environment is related to the child, so the child can adapt itself to live in the environment that the mother sees. It's nature's Head Start program. It's basically designing each individual human to fit the environment that they're supposed to be born into. Why is that relevant? Well, let me show you this. Let's see, I'm going to have to bring my microphone down here. This is, I'll just tell you what it is, and I'm going to play it. This is a video that was made by pre and perinatal organization in Italy, so it's in Italian. What it is a sonogram of a live process of watching the baby respond while they created noise and a ruckus in the background. The concept that we always believe that babies are not conscious, watch this. I'll play it a couple times so you can see it. Can you hear that? Watch the baby jump in the process. Watch the baby. What's the point? The point is that babies are conscious within the first month of development. They're conscious of the environment. They're conscious of what their mothers are aware of. The reason that it is required that they adapt to the environment perceived by the mother. So the truth is, while doctors are just looking at what nutrients the mother is providing for the child, psychologists should be really looking at what environmental information is the mother providing. Why? Because of this. I told you that the hormones run through the body under stress, and they change the blood flow, right? You saw that in the HPA axis, how the blood goes from the viscera to the muscles, right? How the immune system gets shut down, how the blood is squeezed from the forebrain and pushed to the hindbrain. Well, the signals that the mother has experienced cross the placenta. And so the baby is undergoing the exact same physiological response the mother is undergoing. The reason why this is important is what develops in the child is relative to how much nutrition is being received. So which organs get more blood develop more. Organs that get less blood develop less. So in the process of development, the mother's perception is altering the blood flow in the child. And this is a recent article that talked about how altered blood flow and changes alter the flow of the development of vessels and the cardiovascular system in our own bodies as fetuses, which then come back to haunt us later in life as cardiovascular illnesses and other problems. And it just really says that stress hormones in the womb alter the size and growth of the babies because they change the blood flow and enhance different organs to develop, and that these flow changes alter the vascular patterns, which are then create problems later on in life. And the issue about this is illustrated beautifully in this. These are two genetically identical mice. Genetically identical, but they're growing under two different environments. One growing under a growth-supporting environment, and one growing under a stress environment. Now let me illustrate what happened to them. Where does the blood go? Just think about it. I told you this. When you're under stress and the adrenal hormones are released, what's the first blood change? Where does the blood go? From where to where? From the viscera to the musculature. Look at the muscle size, the body mass, illustrated on this one. Look at the body mass illustrated on this one. The body is twice as big. Well, that's a compensation has to happen. If you're sending extra blood to the body, you're taking blood away from something else. Well, I'll give you an example. Where's the blood flow go when you're under stress from the brain? From where to where? From forebrain to hindbrain. Look at the forebrain development in a growth-supporting environment. Look at the forebrain development in a stress environment. You reduce the size of the brain approximately 50%. Relevance? It has now been determined that, these are articles in Nature, the heritability of IQ. 48% of intelligence is based on genes, 52% is based on the prenatal environment. That a mother can extend or subtract the intelligence of their child by up to 50% based on the stress levels that she finds herself in during the developmental process. Why is this relevant? Because go back and look at this. What is the difference between this child and this child? This is a brainiac. This is an athlete. What is an athlete? An athlete has a large muscular body. Look at the hindbrain size. Look at the large bulb behind the forebrain. That's a well-developed hindbrain. Function, muscle coordination. Point. There was a book called The Bell Curve. It tried to say that intelligence is genetic and that we're breeding a more intelligent and a less intelligent population. It's totally a Nazi fascist concept. The reality is this. Intelligence is 52% environment. That especially inner city children and minorities who are under such stress to survive, that their children will naturally turn into the children on the right only because that's how they have to respond to the environment. They lost 50% of their intelligence not because it wasn't genetic, they lost it because they put the blood into growing musculature and hindbrain, which makes them wonderful athletes but less intelligent. And the reality is that it's not in the genes, it's in the environment. Okay? And then this article came out recently, and this is very critical because the traditional assumption is that you can only pass on traits that you pass on with your genes. This article, I'll just read the summary. They have shown that environment can trigger differences in behavior and in stress-related gene expression that are passed on to the next generation. In other words, the environment of conception and development can alter the genetics of the child. Why is that relevant? Because your thoughts and your perceptions can alter not just your child, but pass it on to subsequent generations. It doesn't even go through the genes. It's the environment that overrides the genes. It's called epigenetic control, that the genes, you may have genes, but the expression is not due to the genes. It's really due to the response of the environment. The point is, we have totally ignored this, thinking that genomes are closed system and you're just a victim of your heredity. It turns out, no. If you're a victim of your environment, not your heredity. You can change the environment and you can change your body. You're not a victim. Why? Because you can increase your IQ, as it's been shown. Children taken out of orphanages and adopted into good homes can increase their IQ up to 20 or more % based on the home that they get into. IQ is not fixed. Intelligence is a variable of the environment, and therefore we should not be giving up on kids with less intelligence. We should be giving them a better environment. In conclusion, the body and the cells are like cameras for this reason. Whatever is in the environment, the camera lens picks it up and focuses on the film, and the film makes a complementary copy of what's in the environment. Got it? The cell is very much the same way. Whatever's in the environment, the cell membrane, as the lens, picks it up through the receptors and focuses it on the film, which is the gene. The genes are the film. And therefore, I will make a perfect complementary copy inside of what is seen on the outside. You become physically complementized to the environment that you find yourself in. But on the other hand, we also know this. When we are in the environment and we rewrite the genes to respond to the environment, we create a layer of receptors between the environment and the genes. This is, you know what this is? It's a filter. It's a belief filter that gets between the environment and your genetic expression. Your beliefs will then select your genes according to what you perceive. The only thing that will come through the filter is what you have learned to expect to come through the filters. If you have a receptor for a red light, can you see green light? No, not with that receptor. If you have a receptor for toxin, can you see healthy things? No. If you have receptors for fear, can you see love? No, those receptors don't pick that up. You see what your receptors see. Your receptors are learned. So therefore, you create filters between you and the environment. Here's the environment. Here are the beliefs. Here are the cells. It's the beliefs that select the physiology and behavior of the cell. So therefore, in conclusion, we are not victims of our genes. We're victims of our beliefs. The beliefs can be changed. There's an old concept that belief change is hard, especially if beliefs start a long time ago. And let me tell you where the fundamental issues that people have not recognized. During prenatal development, from the time of conception, that's when beliefs are instilled into the child through the mother's physiology programming the body of the fetus. Why people fail to understand this is that we keep looking for issues in our lives that may have affected us when it may have been birth traumas that have affected us. And so rebirthing becomes a major issue to re-understand the perception that brought us in here and shaped who we were before we were born. Much of the perceptions that we got before being 4 years of age. You can't find those receptions in your consciousness. You didn't even know you got them. And can I talk a couple of minutes? I know it's a zero. I got a zero, but I need to finish this, because here's the intellectual part of it. The brain has active consciousness and active subconsciousness. What is the subconsciousness? Hardwired learned experiences. When you hardwire and you learn it, it's like a reflex. When I hit my knee and then kick, I don't bring it into my consciousness. It's a direct in-out. When I learn something, when a stimulus comes in and I know the response and I learn it, it's a direct in-out. It doesn't come into my consciousness. So I'll give you an example. On the way here, you're driving in the car and you're talking to somebody in the car and you realize you're getting in this very heated conversation and everything's real exciting and you realize, you've just been driving 10 minutes and you didn't pay attention to the road. And the reality is, of course you paid attention to the road, but you did it without consciousness. Why? Because traditional routine things require no consciousness at all. I can take the consciousness out of most people in our workaday world, and you will not notice the difference in their entire life. And the reason is this. When a reflex comes up, it does not come into consciousness. So the behavior that you're expressing most of it is transparent. Why? It doesn't come into your consciousness to see what you are doing. You do it spontaneously. Well, this is the interesting part. It separates consciousness from subconsciousness, so I can do subconscious things, drive the car, walk around, do all these things without thinking about it, while my consciousness is involved with any other different kinds of things. I'm working on 2 levels. And the problem with it is this. If we are working on the learned subconscious behaviors, then these don't have to come into our consciousness. So you can watch somebody in their workaday world where their consciousness is now playing while they're on the job, and they're thinking, I wonder why people don't like me. I'm really such a nice person. And somebody comes up, and right while you're in the middle of the thought, they bother you, and you say, okay, get out of here. Can't you see I'm thinking? I wonder why people don't like me. And the reality is this. The consciousness part of wondering about why people don't like them, the telling that person to go away never came into consciousness. It was just like driving the car. I didn't even see it. And the issue is, therefore, whatever comes into consciousness doesn't have to go into subconsciousness. Subconsciousness is hardwired. You can lose your consciousness and walk through the day and do everything through reflexive behavior. And the issue about it is this. You cannot ignore something in your subconscious, just say, oh, I don't want to pay attention to it. It's not up to you to pay attention to it or not. It's already pre-wired to be reflexive. The signal comes in, you're going to make the response whether you want to pay attention to it or not. So the point is, the only way to change your behavior is to reprogram the subconsciousness. And the reprogramming of it is a process. It can't be done just because it said, okay, I want to lose weight. Well, the concept, because I'm consciously want to lose weight, doesn't change the programming that gave me the weight that I have. I have a weight that reflects some learning. So therefore, if I try to reduce my caloric intake, you know what my body does? It reduces my metabolism. Why? To keep my body exactly in the same place as the thought was inside my subconsciousness. You want to lose weight, you've got to change the beliefs that give you the weight, not the consciousness that says, well, eating less is all I need to do. Your point is you have power, but it takes an exercise to go from your consciousness into your subconscious. You can't just say, do it. The reason is, it's wired. It's wired in the subconscious, hardwired. You have to change the programming. There are many different ways to do it. I will just leave one way from my dear friend Rob Williams. This is a site called www.psych-k.com, and it shows you how you can get into your core beliefs, because your consciousness cannot access your core beliefs. You cannot use the consciousness to find what your core beliefs are. It has to do with mathematics, very simply. The consciousness platform is very small. The memory base is thousands and thousands of times larger. It's very hard to scan that. This is a great site because people always ask me, what can you do about it? This is how you can change belief in about 10 or 15 minutes. Fundamental beliefs change, and I've seen it for 12 years where people's beliefs have been altered, and 12 minutes and their whole lives have been changed from that moment on. Because there's a way of introducing beliefs that involve synchronization of right brain, left brain, because when it becomes synchronized, there's an open opportunity, a window for reprogramming the computational material. So I want to leave that because people always ask, what can I do? That is what you can try anyway. I suggest that. I'm sorry for the rush. I tried to tell you all kinds of things. Thank you very much. Thank you. Oh.